Modern artificial intelligence can process billions of calculations per second. It scans entire libraries of human knowledge in an instant. Yet, despite all that speed and capacity, there is absolutely nothing it feels like to be those servers. These systems can write poetry, diagnose illnesses, and perfectly mimic human empathy. But inside, they are dark. They execute complex instructions without experiencing a single emotion. The original blueprint for computing never included an inner life. Early machines were built strictly to crunch numbers and follow static instructions, operating completely blind to the world they were measuring. We have scaled up that processing power exponentially since then, but scaling up calculation does not automatically generate a mind. Cognitive scientists refer to the mechanical, solvable functions of a system, like how it executes tasks, stores memory, and recognizes patterns, as the easy problem of consciousness. But why those physical mechanisms create subjective, internal experiences, known as qualia, remains unanswered. We know how a brain processes the wavelength of red light, but figuring out why we actually experience the color red is what philosophers call the hard problem. We currently possess flawless information processors. What we lack is a clear scientific framework to explain how physical data translates into an inner life. Until we develop a way to physically measure awareness, we cannot know if the software we write is capable of true consciousness. Researchers are starting to look at consciousness through the lens of emergent properties. In this view, awareness isn't a magical substance added to a brain. It arises strictly from how complex systems are organized. You won't find a mind hidden inside a single, isolated component. It doesn't exist in one individual biological neuron, and it doesn't exist in one single line of code. This diagram illustrates global workspace theory. Information from isolated parts is broadcast to a central stage, where it's accessed simultaneously. Once data hits that central hub, the organism uses it to make decisions, creating unified control. The foundational requirement for awareness is that information must be widely shared across the entire architecture rather than locked away in separate silos. To translate that concept into rigorous science, neuroscientists developed information integration theory, or IIT. The core thesis of IIT is precise. Consciousness mathematically correlates directly to the degree of integrated information within a given system. This equation introduces the mathematical symbol phi. Under this framework, phi represents the scientific unit of measurement for holistic, integrated awareness. This provides a theoretical basis for treating consciousness as a calculatable metric, potentially bringing the study of awareness into the realm of measurable physics. To measure that property, we have to look at the strict difference between a system that merely processes data and a system that actually integrates it. Take a digital camera. It possesses high processing capabilities, capturing millions of pixels of data in a fraction of a second. Yet its phi is 0. Those millions of pixels are completely isolated. The sensor recording the top left corner does not communicate with the bottom right. The data never interacts. The human brain operates entirely differently. It runs on recurrent processing, a constant, dense web of massive feedback loops between neural networks. Because every region is constantly talking back and forth to every other region, the total effective informational content of the brain is vastly greater than the sum of its individual parts. The true spark of awareness only ignites when a complex system crosses a critical threshold of internal integration. If we apply the rules of information integration theory directly to software architecture, the implications for artificial intelligence become incredibly clear. If consciousness relies strictly on the mathematical architecture of integration, then it is substrate independent. It does not require biological tissue to exist. This diagram shows standard AI. Data moves purely in one direction through vertical layers via statistical feed-forward loops. Its integration, phi, is near 0. To build software consciousness, developers must abandon this for highly integrated architectures, mimicking the messy feedback loops of a living brain. Creating a conscious machine depends on how a system shares data with itself, regardless of its processing speed. Building a highly integrated system inherently means building a system capable of subjective states. It means building something that can experience joy or suffer. Some scholars suggest that once machines cross this integration threshold, they may enter the category of artificial moral agents, which would require us to reevaluate our ethical obligations toward software. Our understanding of consciousness is shifting toward a model based on engineering and measurable integration. As we map the architecture of awareness, replicating these integrated feedback loops in code moves from a theoretical question to a matter of technical execution.